Our lab is interested in finding new ways to prevent melanoma. Melanoma has been one of the fastest increasing cancers in incidence over the last several decades. Back in the 30s, Americans had a 1 in 1,500 chance of getting it in their lifetime. Now we're about 1 in 50 or 1 in 60 of us are getting melanoma. So that, coupled with the fact that it can be potentially very deadly, causes about 10,000 deaths a year in the United States, means we have to do something to prevent this disease. So we're interested in understanding how early events happen to give somebody melanoma. So if this is your skin in cross-section, and this is the outside, and this is the inside, the skin's got a lot of these cells called keratinocytes, and this is what your skin uses to protect the body, from chemicals and things like that. And it sloughs off. These keratinocytes kind of slough off every month. You replenish your skin. Way down deep in the layers of the skin are these interesting cells called melanocytes. And these are the pigment-producing cells of the skin. Why we're interested in this is they also are the precursors for melanoma. And it's when your skin gets UV light, from the sun or from tanning salons or something like that, UV can penetrate, cause damage in these cells, which then leads to, they're turning into cancer, and that's melanoma. And so when we're looking at ways that we can protect the skin to prevent some of this damage up front to be able to prevent melanoma. So if we look at a melanocyte now, if I focus down on here, and this is its membrane, there's a protein on this membrane called the melanocortin-1 receptor that turns out to be a very key molecule in determining your melanoma risk. And the reason why this is important for Americans is because so many of us, probably in the neighborhood of 6 to 8 million of us, have an MC1R with, that doesn't work particularly well. This tends to be found in people who are fair-skinned, can't have they burn rather than tan in the sun, and they're at higher risk of melanoma than the rest of us. And so trying to understand this pathway and how this protects melanocytes against UV damage, our goal is to develop some treatments to exploit this pathway and prevent melanoma. So what we know about this pathway is that it can be turned on by little hormones in the skin. I'm not going to get into the details of that, but this causes a signaling pathway that has two effects for melanocytes. One is they make more pigment, or melanin, and the melanin deposits all in the skin and acts like an innate sunscreen. You can't wash it off. The more you have, the better protected you are. UV gets blocked and can't get down here to cause its damage. The second one, which is very important as well, is this also regulates DNA repair, And so if UV light gets down to these cells and it causes mutations or causes damage that would lead to mutations, these cells can protect themselves by repairing that damage, and that's called DNA repair. And so our lab has been very interested in the molecular pathways, the links between this hormonal pathway up here and DNA repair and pigmentation. Our goal is to develop creams, for example, that you could put on before you go out in the sun and get less UV damage because you have more pigment to begin with, and also make your melanocytes ready to get rid of any damage that they get so you get less mutations. This would turn into less melanoma. The Melanoma Research Alliance grant is for us to study some of the other factors that impact this pathway. So there are both hormones that can turn it on and there are hormones that can turn it down. And the MRA grant is for us to study some of these newly appreciated hormones that could turn it down. Specifically, there's a hormone that gets turned on when your skin has infections or inflammation, and we'd like to understand whether or not if this hormone called beta-defensin 3 would affect melanocytes' ability to do these two things here. So by understanding how the good stuff happens, this pathway works, and how potentially could be blunted, we think we can develop some novel melanoma preventive strategies to reduce the risk of this horrible disease.